Okay, so in this video, I'm going to continue to go over practice problems. So I'm going to solve 3 problems in practice problem set for test 2. And then these 3 problems from the chapter 4.9. Okay, so the first one is, you can see that here. I'm going to call. We're going to see problem number 2 in chapter 4.9. So let's see the time to failure to in days of a starter motor in a vehicle is modeled as a Weibull distribution, with the delta is 3,000 and beta is 1.5. All right, so what's the Weibull distribution? So the Weibull distribution, the random variable x denote the time until failure. And then PDF is like this. Yeah, I know it's a little bit complicated. Many parameters involved. But don't worry about that. Most of the problems, those parameters are given. Okay, so you just plug them into the formula. Okay, so beta over delta times x over delta to the beta minus 1, and the e to the minus x over delta to the beta power to the beta. Okay, so if beta is 1, and then the considering the 1 over lambda as 1 over delta as a lambda, then that's PDF gonna be exactly same as PDF in exponential distribution. Okay, we'll see that. And then CDF gonna be 1 minus e to the negative x over delta to the beta. Okay, and then mu and sigma square is given. Okay, so now then here what's gamma is the gamma function. We haven't seen this one, right? You know, when you cover the when it's in the what gamma distribution. So gamma are, you see, keep in mind, I told you, just keep in mind 3 the property of the gamma function. Okay, gamma r is equal to r minus 1 times gamma r minus 1, and then gamma r is equal to r minus 1 factorial. Here at the second property, we assume that r is the natural number. Okay, and the gamma 1/2 is a square root pi. All right, so we'll see the problem in excuse me. See problem the 4.9.2. Okay, so 4.9.2. All right, so what do we do? So question is this. And by the way, see delta is given. Delta is 3,000, and then beta is 1.5. Okay, and question A: what is the probability that a starter motor fails within 2 years? The unit of random variable in days. So we have to convert 2 years to days, which is 2 times 365, right? The probability that x is less than 2 times 365. Okay, so now that is equal to what? This is equal to the f of x, right? Which means that here x means 2 times 365, which is 730, right? Okay. So that is equal to 1 minus e to the negative 700, the it's just yeah, so 700, just give me a second, 730 over delta is 3,000. Okay, to the beta is 1.5. Okay, so that approximately 0.113. Okay, the B. What is the probability a motor fails in less than 3 years, given that it has has lasted more than 2 years? So that's the conditional probability. So probability that x is less than 730. Given that x is greater than 3 times. I'm sorry, not 700. This is 3 times 365, and then 2 times 365. Okay. Yep. So that is equal to, what's the formula of conditional probability? This is equal to what? Probability that x is the greater than 2 times 365 and then less than 3 times 365 over probability that x is greater than 2.365. Is it? Okay. So this is equal to what? Uh, give me a second. So is it right? So let me see. Yeah. Okay. So then we can say that this is equal to what? Probability that the numerator, the denominator is the what? Actually f of 2 times 365, right? What about the numerator? That's going to be equal to probability that x is less than 3 times 365 minus probability that x is less than 2 times 365. Okay. Because the x denote the time to failure, right? So it means that what the probability that x is between 2 times 365 and 3 times 365. That means that the x what the x will not the starter motor will not failure within 2 times 365. So we have to subtract probability that the failure happen within the time 2 times 365, which is this. Okay. So now then this is equal to, the bottom one is what? 1 minus so 1 minus what? Oh, by the way, the top one is 1 minus, right? I'm sorry, this is the not CDF because x is greater, right? But this is equal to 1 minus probability that x is less than 2.365, so which is 1 minus f. So this is equal to 1 minus e to the negative, and then 330 over delta is 3000 to the 1.5, right? Okay. The top one is what? 1 minus, you see, e to the minus 1095 over 3000, okay, to the 1.5 minus 1 minus e to the minus 730 over 3000 to the 1.5. Okay, is this. Okay, so this is approximately 0.096. This is approximately 0.096. Okay, so now the next one, C. Compare your answer in the previous part to the probability that a motor fails in less than 1 year and comment on whether comment on whether the lack of memory property applies to this distribution. So look at the probability that x is less than 730, and then probably the x is between 7,009. X is less than 2 years, and then probably the x is between x is less than 3 years, given the x is greater than 2 years. If the Weibull distribution satisfy lack of memory property, then these two answer problem C, probability that x is less than 1 times 365, that must be equal to if the lack of memory property is satisfied in Weibull distribution, then this must be equal to a probability that x is less than 3 times 365, given that x is greater than 2.365, right? So if the lack of memory property. Okay. Oops, sorry. Okay. So, but I don't think these two properties are equal. Why? Because the left-hand side, this is equal to what? 1 minus, not 1 minus, I'm sorry, 1 minus the what? The 1 e to the minus 365 over 3000 to the 1.5, which is approximately what 0.042. Okay, so left hand side 0.042, right hand side we got this one from problem B, which is 0.096. So two, you know, there, I mean, the probability in the left hand side is different from the probability in the right hand side. So Weibull distribution doesn't the lack of memory property doesn't apply to this the Weibull distribution. Okay, so last problem D. Okay, so in D, question is this: suppose that the time to failure in days of new starter motor follows a Weibull distribution with a delta is 4,000, beta is 2.0, and that lifetime is defined as the time exceeded by 90% of motors. Which motor has a longer lifetime? All right, so what we're gonna do, yeah, we gonna find out the what? Well, as you can see that here, I mean, this, okay. So the first one, we're gonna find out the what? The time where the probability that the what? The motor, the start motor failure occurred is greater than X equals 99%. What that means? So we want to find the probability that X is greater than X is equal to 0.99. Okay, which means that we have to find out time. I mean, when the start the motor failure occurred, where the probability is 0.99. Okay, so this is what is this? This is equal to 1 minus probability that X is less than or equals X, right? Okay, so that is equal to 1 minus f of X, right? So this is equal to what? 1 minus e to the negative X over delta to the beta, right? So that is equal to what? Just e to the minus X over delta to the beta's power, which is e to the minus, what's delta? Delta is what? 3000, right? The beta is 1.5. Okay. So that's going to be what? So we have to find out what? That must be equal to 0.9. We have to find out the X where this guy is equal to 0.99. Okay. So we solve it. Okay. We solving here. That means negative, what? Give me a second. X over 3000 to the 1.5. Okay, is equal to natural log 0.99, right? So now, okay, so now then X over 3000 is equal to minus natural log 0.99 to the 1 over 1.5, is it? Okay, and then X is equal to 3000 times negative natural log 0.99 to the 1 over 1.5. Right. So this is approximately what? 139.71 days. Okay. So now this is the what here we apply the Weibull distribution with delta is 3000 and beta is 1.5. Okay. So now the lifetime for that Weibull distribution, the lifetime where the probability that the probability is the greater than 99% is 139.71 days. It means that 139.71 days, it guaranteed that the starter motor will not starter motor failure will not be occurred. Okay, so we can guarantee 99%. Okay, 99% the probability. So now then, the problem D, they ask us to compare this one with what? The another variable distribution with delta is 4000, beta is 2. Okay, so now then, probably that let me use other letter for the random variable of the variable distribution. It's greater than dy is equal to 0.99. This is equal to what? E to the minus y over 4000, right? To the second power is equal to 0.99. Then minus y over 4000 to the second power is equal to 0.99 of natural log. I'm sorry, natural log. So now the y over 4000, this is equal to negative natural log 0.99 in the second power, 1 over 1/2. Okay, I'm sorry. So that y is what? 4000, okay, times negative natural log 0.99 to the 1/2. Okay, this is approximately 401.01. Okay. All right. So the we can say new new starter motor following the Weibull distribution with the delta is 4000, beta is 2, has a longer lifetime. Okay, so new starter motor is better than a better quality than the previous starter motor, right? You can say that. So now next one, next question is this. Let's see. All right, so suppose that the lifetime of a component X is modeled with a Weibull distribution. Beta is 0.5, delta is 4000. Okay, so give me a second. All right, so find out the probability that X is greater than 3500, and then B and then C are conditional probability. Okay, let's figure out that. So this is a 4.9.3. Okay, so question A, we'll find the probability that X is greater than 3500. Okay, it's not a big deal, right? So this is equal to what? 1 minus the f of 3500, right? Okay, so this is equal to 1 minus e to the what? Negative x over delta to the beta's power, right? So which is the e to the negative x over delta is the problem says that delta is 4000 and the beta is 0.5. Okay, so the answer is 0.3, approximately 0.392. 0.3924. Sorry. Okay. So this is approximately 0.3924. So now next one, B. So probability that X is greater than 6000, given that x is greater than 3000. Okay, so that is equal to what? This is equal to probability that, look at this. In this is conditional probability, right? Conditional probability, numerator going to be what? The probability that what? Probability that the both event will be occur, right? Kind of. So what's the kind of common event of both event? Okay, you see that? X is greater than 3,000, 6,000, X is greater than 3,000. X is greater than 3,000, that's the, what? Is included in that event, right? So then this numerator going to be what? Probability that X is greater than 6,000, right? Okay. Now then, what? Numerator going to be what? Just probability that X is greater than 3,000. So that is equal to e to the negative x over 4,000. I mean 6,000 over 4,000. Okay, to the 0.5, right? By the way, in question A, the x is what? 3,500. Okay, 3,500, right? Sorry. And then back to B. Okay, this is the top one, and denominator is e to the negative 3,000 over 4,000 to the 0.5. Okay. So this is approximately, this is equal to 0.6986. Okay, and then C. Suppose that x is an exponential distribution. Let me share the screen. Okay. So suppose that x has an exponential distribution with a mean equal to 4,000. What does that mean? I told you in a Weibull distribution, if beta equals 1, then the random Weibull random variable gonna be exponential random variable. Okay, with the lambda gonna be 1 over delta. Right. So what that means, in the PDF Weibull, the PDF in Weibull distribution, f of x is equal to beta over delta, and then x over delta to the beta minus 1, and the e to the negative x over delta to the beta power. Okay, it's this. So if beta equals 1, and then the lambda, set lambda equals 1 over delta, okay, what happened? Then f of x becomes what? 1, I mean lambda, is it beta of lambda going to be 1 over delta, which is lambda, right? And then if beta is 1, then that term will be gone. And then the exponential term going to be e to the minus lambda times x, right? Okay, does that make sense? So this is exactly the same as the PDF in an exponential distribution. Okay, so back to problem. So now we find the probability under that assumption. I mean, assumption that the x has an exponential distribution with a mean equal to 4,000. Okay, so now then the x we calculate that probability. Probability x is greater than 6,000. Given that x is less than x is greater than, oops, sorry, x is greater than 3,000. Okay, so what is this? This is equal to, we saw that, right? That is equal to what? This is the exact same as that problem in problem B. Okay, so we're gonna adopt this one. Okay, then this is equal to probability that this is equal to probability that what x is greater than 6,000 divided by probability that x is greater than 3,000. Right? This is equal to what? Lambda. So what is lambda? 4,000. Okay, the problem says that exponential distribution with a mean equal to 4,000. Do not be confused with with that the lambda is 1 over 4,000 now, okay? And there is a neither 4,000 is not the, I mean, don't be confused with that 4,000 is lambda, delta, no, 4,000 is not delta, 4,000 is lambda, okay? So then you may say that, okay, so 4,000, just say the lambda is a 4,000, that means delta is 1 over 4,000. You can say that, but eventually we're gonna plug in, you see that right there? Eventually we're gonna plug in lambda, okay? You see, right there. So we don't have to figure out 1 over delta, okay? All right, the problem says that delta is 4,000. So for example, delta is 4,000. All right, then 1 over delta, since lambda is equal to 1 over delta, so 1 over delta is 4,000, right? So delta is 1 over 4,000. You don't have to figure out this. That makes you more confused, okay? You don't have to do this. Just plug in 4,000 into here. PDF in exponential distribution. So now then this is equal to what? Also we see this is equal to what? What 1 minus, let me see again, 1 minus f of 6,000 over 1 minus f of 3,000, right? Okay, so this is equal to, by the way, what's f? F is what? Oh, this, the f of x in Weibull distribution, 1 minus e to the negative x over delta to the beta. But in an exponential distribution, beta is 1, okay, and the 1 over delta is lambda. So we got this, 1 minus e to the negative, what? Delta times x, right? So we got, so then what? 1 minus 1 plus e to the negative lambda x, which is e to the negative lambda is what, 4,000? Yeah, give me a second. Let me see. Give me a second. Oh, give me a second. Yeah, so here I was confused with I was confused with the lambda and the mean. So let's see the problem again. So you see right there. So problem says the mean equal to 4,000. Here mean is expected value. So right there. So mean expected value E of x is 4,000. But in exponential distribution, E of x is what? Actually 1 over lambda, right? This is equal to 4,000. So which means that lambda is 1 over 4,000, right? Okay, I'm sorry. So the what? Then we're gonna get this e to the minus x. X is here 6,000, right? 6,000 over 4,000. Okay, and then over e to the minus 3,000 over 4,000. Okay, so and then putting them into the calculator, then it will give us the what? 0.4, approximately 0.4724. Okay, so now next one, and the last question. Suppose that x has a Weibull distribution with beta equals 2 and delta is 2,000. So determine the following. Round your answer to 3 decimal places. So probability x is greater than 3,500. Yeah, so let's see. This is a 4.9.4. So beta equals 2, and then delta is 2,000. Then probability that x is greater than 3,500. That is equal to what? This is equal to 1 minus f of 3,500, right? This is equal to what? e to the minus x over delta to the beta power. Okay, so which means that what? E to the minus 3,500 over delta is 2,000 and then beta is 2. Okay, this is approximately 0.047. Okay, all right, so now B. This is question A, and the question B. For an exponential random variable with the same mean as the Weibull distribution, so we need to figure out the first mean, okay? So we need to figure out the mean in the Weibull distribution. So the Weibull distribution mean gonna be delta times the gamma of 1 plus 1 over beta, okay? So what's delta? Delta is 2,000. And then beta, since beta is 2, so we're gonna get gamma of 1.5, okay? See? Then this is equal to, I'm gonna use that property, gamma of r is equal to r minus 1 times gamma r minus 1. Applying this one here, you're gonna get this 2,000 times 1 0.5, I'm sorry, 0.5 times gamma of 0.5. Okay, then that's gonna be what? 2,000 times 0.5 is 1,000, right? And then times gamma 0.5 is what? The square root of pi. Okay, so that's the expected value of the Weibull distribution. And the problem says that exponential random variable has the same mean as the Weibull distribution. Okay, so what? In the exponential distribution, what? Exponential distribution, the mu is 1 over lambda, right? This must be equal to 1,000 times square root pi. Okay. Now, then we find the probability that x is greater than 3,500 under the exponential, and this is exponential random variable. In this problem, we're gonna compare the probability that x is greater than 3,500 in the Weibull distribution with the that probability under the exponential distribution. Okay. All right. So this is equal to what? This is equal to e to the minus x, lambda times x, right? In our exponential distribution. So that is equal to e to the minus 3,500. Okay, because the 1 over lambda is this. Then what is lambda? 1 over 1,000 times 1,000 times square root pi, right? So 1,000 times square root pi. Okay, right. So this is equal approximately. This is equal to 0.19. Okay. So question C. Comment on the probability that the lifetime exceeds 3,500 hours under the Weibull and exponential distribution. Then yeah. So what's the the comment? The probability that the lifetime exceeds 3,500 hours is greater than under the exponential. The greater under the exponential distribution than under this Weibull distribution model. Okay, so I solved the 3 problem in 4.9. Okay, in this video. Okay, all right. The okay, next video. The yeah, so I'm gonna review. I'm gonna cover the more problems in practice problems, and then I'm gonna cover 4.10. Okay.